Good morning, everyone. So I would like to thank CHI for providing me with this opportunity to present at 55th International Conference on Water Management Modeling. So I'll be presenting a session on application of Icwmm software for design of water distribution network for Jal Jeevan mission. So here is a brief of my bio. I am Sriranga KM, working as a project engineer at Water Dynamics Private Limited, Bangalore, India. I have my bachelor's in civil engineering, and presently I'm enrolled for my master's in environmental engineering, and I'm expected to graduate from it in December 2022. I have about 6 years of experience in professional engineering. In that, about 10.5 years in water resources engineering, and I have been involved in developing hydrological and hydraulic models for stormwater master plans, river irrigation schemes, and flood inundation mapping. I have also been involved in design of sanitary networks and water distribution systems. Let's get started with the agenda here. So first, we'll discuss in brief about what this Jal Jeevan mission is all about and its timeline. We'll also touch upon why there was a need to come up with innovative and faster design mechanisms. Then we'll, for a short period, we'll also discuss on how a typical multi-village water supply scheme looks like. Then we'll discuss in detail about the improvised design methodology that we have come up at CWD with the help of Icwmm software. And in the end, we'll summarize where and all we have been able to save time significantly with the help of tools that are available at designers' disposal in Icwmm. Now, to get started, what is Jal Jeevan mission all about? Jal in Sanskrit means water, and Jeevan means life. So the mission of this project is to provide a safe, treated, and adequate drinking water to all the households in rural India by 2024. So the project was launched in 2019. So in a short span of 5 years, the plan is to provide water to 192 million rural households in India. So you can imagine the scale at which this project is being mounted. And the total budget of this project is approximately about 53 billion US dollars. So with the accelerated schedules and the timelines, and also the scale of this mission, there was an opportunity for private sector consultants to come up with innovative design mechanisms that reduces the time required for designing a distribution system. And this is where we at CWD, with the help of Icwmm software, have come up with a very innovative design mechanism, which once understood can be used to replicate designs for hundreds of villages in a short span of time. Now, before we discuss in detail about what the methodology is all about, let us first understand what a typical multi-village water supply scheme looks like. So, when we speak about any water supply scheme for that matter, one of the first thing a designer does is to identify a sustainable water source. So it could be a river if the area of our project interest is blessed with rivers. And if there are no rivers, then we'll obviously go for a subsurface water source. So we'll construct an intake structure in that sustainable water source location. And by gravity, you will take water to jack well. And on top of it, you will have a pump house. And two vertical turbine pumps will pump water through a raw water rising mine to a water treatment plant. And in this water treatment plant, water gets treated as per the health guidelines that have been set in place. And once the water is treated here, it is again pumped through clear water pump station to master and zonal balancing reservoirs. So usually these balancing reservoirs are placed at a higher altitude, so that from here, the water can be supplied by gravity to overhead tanks in the respective villages. So here I've just shown village OHT1, village OHT2, village OHTN. So depending on the topography and terrain of our project interest. So this number of villages may vary somewhere from 25 villages to even 500 villages. So now let's just start with one of the village. So once the water reaches a particular village, from that over that villages over time, we need to have an again in-village water supply scheme so that water can be supplied to individual household. So for this in-village water supply system, we will be discussing in detail now. So when we talk about design methodology for water distribution system, we can usually bracket them into three main subheadings. So the first one is, of course, survey. The second one is design and modeling, and the last part is reports and maps. And in survey, the first activity is to do a requirement survey to understand the topography. And once you are done that, a survey team will be sent to carry out topographical survey before, let's say, 5 years or 10 years before, usually it was carried out using total stations or DGPS. Now with the advent of drones and them also being available at very cheaper rates, we have gone with a drone survey here, and also we'll also send one more set of survey team to collect total household information. So once we are done with collecting all the data that is required, we'll calculate the water demand that is required for that particular village, and we input these demand calculations into a modeling software. And with the total pipe network digitized and constructed, we'll carry out the modeling iteratively to arrive at pipe diameters, ensuring that there is enough residual pressure in the endpoints. So instead of going with traditional method of surveying, that is GPS, we have gone with drone survey. So what this basically does is, because the drone outputs are GIS enabled, and PCSWIM also supports GIS enabled files to be imported without any modifications as they are. So this drone output, along with the tools available in PCSWIM, eliminates the need for designer to switch between different interfaces like AutoCAD, QGIS, and designing software when he is modeling. He can do all of that right within the PCSWIM interface itself. So this is the first step where we have been able to cut down on the time needed for designer to shift between different interfaces and do all the activities within PCSWIM itself. When we talk of drone outputs, the first output is obviously very high resolution orthomosaic imagery. We can get resolution as high as at 1 centimeter or 2 centimeters now, and other output is digital elevation model. So we can use this information to designers' advantage. Now moving on, once we have the drone output, once we have drone survey completed for a village, and we have orthomosaic and TM as our outputs, what we did was we created a village map again within the PCSWIM software itself with the help of new polyline shapefile, and that village map was printed and given to our survey team to go and collect household information in each road. So you can see here that in this particular road, we have, you can see 4 is written here, and on right side it is written 3. So what it indicates is, in this particular road, there are 4 houses, and in that there are already 3 houses with tap connection. So we have collected what are the total number of households in this particular road. We also have the information of whether that particular household have a tap connection or not. So now once this field activity is done, usually what is done is, again another set of team is sent back to a site to validate the data collected. But what we have done here is, because we have a very high resolution orthomosaic imagery, we have created a house count shapefile within the PCSWIM itself to validate the data collected. Now, by eliminating the need for us to go back to the field once again, we are here saving about 1 to 1.5 days of time. So this is the second step where we have been able to reduce the time required for designing. And so the next is another copy of this village map. Existing pipeline infrastructure information will be collected. So you can see here that in this road there is already existing pipeline of 2-inch diameter. Whereas if you come to this road, the existing pipeline is only to this point, and here there is no pipeline. So with this data collected from the site, what we have done is we have input this information into the pieces from interface using description and tag columns. So that is, for example, if we talk of this road, which is here in this village map, so we have used description column and input, say, existing pipeline and proposed pipeline. So I'll come to this point later where I'll explain in detail how this is very helpful in quicker estimation process. And we have used tag column to input the data of the respective road classification on which this pipe is being laid. So you can see here that it is the CCNS, which means CC road with no shoulders, whereas here you can see it is mud road. This data is input here because when we are estimating, the cost required for excavation in mud road is different from the cost required for excavation in CC road. So we have been able to geotag the road classification and also the details of existing infrastructure in the designing software itself. There is no need for us to go back to QGIS or AutoCAD to look at this information. We can view at this information in Icwmm itself. And now we have the data that we need for carrying out designing, and we have digitized the total pipeline network. The next thing that we need to do is allot demand. So the mandate we had was to consider 4 people per household as a standard, and per person the demand to be considered is 55 liters per day. So when we consider 4 people and 55 liters per day and calculate the base demand per house, the demand works out to be 0.003 LPS. That is, if there is one house in a particular road where the pipeline is being laid, if there is one house, then the demand becomes 0.003. And if there are 5 houses in that particular length, then the demand becomes 0.003 into 5. So what we have done is, we have the house count shapefile that we have used for validating site data. And next thing that, as an extension of that, what we have done is we have used description and tag column within the Icwmm to input what are the total number of houses on left side of the road and what are the total number of houses on right side of the road. So, for example, if you take a look at this pipeline here, this is one second. You can say this is secondary distribution pipeline, and there are tertiary outlets here. So if we see this portion here, there are 6 households, and we have input that in a description column because this is the direction of flow. It is on left side of the pipeline, so I have marked it as left side here. And on right side of this pipeline, if you count it, there are 11 houses. We have input that into tag column. And what we have done next is we have used this replace option that is available in Icwmm, and we have inserted the formula that is description plus tag into 0.003, which means sum of total houses on left side of road and sum of total houses on right side of the road, whole sum multiplied by base demand per house, which is 0.003. By doing this in a single shot, we are able to allot the demand to complete distribution network. If you are doing this in other softwares, what you need to do is you need to create an Excel sheet. You have different road classifications saying road A, road B, road C, road C, depending on how big or small the area of extent is, and you need to have house count and calculate the demands in Excel and then copy paste that back into the designing software. But in Icwmm, we don't have to do that. With the help of description and tag column and this formula here, we are able to automatically input it, and again house count is house count also we have that information as a part of validation, so that also need not be created again. This again reduces the time that is required for designing. And of course, as I was saying, the second output of drone survey is digital elevation model. And simply by using this elevation from DM tool, we can assign elevations to all the junctions at once in the model. And if you're doing it in other softwares, you will have to create a contour file, and you will have to convert that contour file into a point file. And if it is not georeferenced, you will have to georeference it, and then extract elevation data from that point file. It will involve 3 to 4 steps before getting the elevation. Whereas in Icwmm, you can do it in you can do that in a single shot. This again saves the time required for the designer. Now, with the pipeline completely digitized and with the demands allotted at the junction, all you are left to do is follow the hydraulic design parameters and design what is the diameter of the pipeline that is required to carry the water with sufficient residual pressures at endpoint. So here we have made sure that the velocity pipelines is not more than 0.9 to 1 meter per second, and we have kept the frictional head losses to less than 5 meter per kilometer, and we have designed the distribution network. And once we are done with designing, as I was saying before, as I showed in the digitization of pipe network, we have input existing and proposed pipeline data in the description column, and its respective road classification in the tag column. And because Icwmm is GIS enabled and it has an inbuilt projection system, you get the lengths automatically. You don't have to input that manually. And of course, we have this diameter from our hydraulic design. All we need to do is we have all the data that is required for estimation in the designing software itself. So all you need to do is export that into an Excel and use pivot table. Once you do that, you will get a summary of what is the total length of existing pipeline, what is the total length of proposed pipeline, along with its respective road classification. If, for example, here the existing pipeline in CC road is 2,200 meters, but we have proposed an additional 5,800 meters of pipeline in CC road in that particular village. So we have all the data that is needed for cost estimation here. And of course, we'll also get the different diameters of pipe that is required in that particular village. So in the last 15 minutes, we have understood with the help of drone survey and the tools available in Icwmm, we are able to simplify the process of designing. So first, starting with drone survey output, we have eliminated the need for designer to switch between different outputs, such as different interfaces, such as AutoCAD and QGIS, and we have independently validated the house count information within the designing software itself. And as far as digitization of pipeline network is concerned, a length is automatically assigned to all the pipe by Icwmm itself. We don't have to input that manually. In other softwares, you'll have to worry about stuff like what is the scale. If suppose you are inputting a orthomosaic into a designing software, you have to first set the scale 1:100, 1:500. Then you'll have to assign the length. We don't have to worry about that here in Icwmm. And we have discretized the information that is very important for cost estimation in the Icwmm itself by using description and tag column. We also discussed how we have allotted demand using automated tools available in Icwmm. And with all this, with all the data in single interface, and also designing happening in the same interface, what we have been able to achieve at CWD is we have been able to complete preparation of detailed design reports for 600 plus villages in a record time. If we consider a time frame between January 2021 to May 2021, so in a short span of about 4.5 months, at that time, we were able to produce reports for 350 plus habitations. That is, on an average, we were producing about 60 to 70 design reports in a month. So again, PCSM software has been there for a long time. And in this project, the problem statement was not to come up with sophisticated hydraulic engineering, that is already set, but instead we had to develop a methodology where once the prototype is set, the designer can replicate the design for hundreds of villages in a very short time. So that's what we were able to do with PCSM. And we have come to the end of the presentation. If you have any questions, I'll be happy to answer.